welcome to the data hosting video in the large-scale machine learning section of ML Expert. Let's say that we were to set up a recommendation service after we have productionized our model. Again, if you want to look at that video, go ahead and reference the productionization video in the large-scale machine learning section. So let's say that we have a recommendation service up and we have productionized a model, and now that model is serving real traffic. Well, let's say a user requests some home page from our app, and this app is going to call getRecommendation for this particular user, and the recommendation will be returned to the app from the recommendation service that is hosting our model, and then the user will get that recommended experience on the home page. So this recommendation service needed information on this user, but how did it actually get it? In order to run the model, it needs the user's features, but really we've only talked about the features existing in two ways so far. One, there could be no features. This would be the cold start problem that we talked about in the machine learning crash course. The other option that we've talked about in the large-scale machine learning section is that they're an HDFS. Remember, that's where the data processing jobs store the final features. Well, HDFS isn't exactly ideal for hosting data in a low latency situation. It's probably a better idea to offer a low latency data serving layer. So for instance, let's say the recommendation service is here, it gets a request, and if we were actually going to use HDFS as a way to serve data to the recommendation service in real time for each user, it could potentially take hundreds of milliseconds to get that data. So what's a better way to do this? So what we could do is we could have Airflow, which we talked about earlier in the series, have some way to recognize when HDFS is updated, and let's say HDFS features are updated every 24 hours. So we would have a hook on HDFS such that every time new features got added to HDFS, Airflow would communicate to recommendation service to tell it to refetch the data from HDFS, and then the recommendation service would asynchronously get all of the data in bulk from HDFS, and then all of that data would be immediately available on the recommendation service itself. So the problem with this is that we're now under the assumption that the data can fit on the host. Here, that host would be the recommendation service. Now, this could mean the data fitting in memory, RAM, or both disk and memory. Tools that we can use to do something like this would be Redis, Memcached, and Tarantool. However, now we have to worry about two ways in which we must vertically scale. So let's say that we have a setup that looks like this. So we still have our Airflow hook, we still have HDFS updated every 24 hours, and recommendation service will bulk load all of the data from HDFS every 24 hours. So now we have some in-memory database, which we talked about earlier, that would be Redis, Memcached, or Tarantool. And this in-memory database, let's say, would store 30 gigabytes of user features. Now, this isn't so unreasonable to have 30 gigs of RAM or memory, and if we wanted to also spill over some of the storage into disk, it's certainly not unreasonable to assume that this configuration could work. However, let's say that we're now getting 1,000 requests per second, and now let's say our model requires more features as well. So now we kind of have to worry about maybe scaling this out in terms of horizontally scaling and adding more hosts for the requests, and perhaps even if we get more features needed, so now let's say we need 1 terabyte of in-memory database storage, this can become prohibitively expensive to maintain such vertically scaled machines. So in order to handle the 1,000 requests per second, we could horizontally scale like this, and so every machine would get 1/3 of the traffic. But we're still stuck with this problem here, where every machine would have to load 1 terabyte of data into it every 24 hours. One way that we can solve this problem is by using something called a distributed cache. This cache would follow the same process as getting a bulk load of data from HDFS every 24 hours. The difference is that every service would now call the same distributed cache, and this distributed cache would actually have multiple machines in it to make a cluster, such that each machine in the cluster would maintain some portion of the data. Now, we're not going to get too far into how this would actually work. It's actually pretty complex when you look at distributed caches, but generally you're going to have some hashing. So let's say that we were storing features for user IDs. You would hash the user ID such that 1/3 of the user IDs would be on each host. But another thing that we need to acknowledge here is we need clients on each of these recommendation service now to make sure that we know which hosts to call for some particular data. As well, we need to manage the membership of each node in this cluster, and we can use Zookeeper to do that for us. Zookeeper would ensure that the clients become aware not to call on particular hosts that are now out of the cluster for reasons such as scaling down, or if that host has just become unavailable. So another important factor that these clients must handle is caching. So if we have an extremely popular item, it's far more efficient to cache these items on the clients themselves and maybe store 1% of what the distributed cache is storing in terms of items that are popular, such that every request doesn't actually have to call out to the distributed cache. So what are some tools that can help us do this? Well, we have Apache Ignite, DynamoDB, specifically DAX or Dynamo Accelerator, and then finally we have Redis, which we can use with AWS Elasticache, which will allow us to horizontally scale out a Redis cluster. So in this video, we talked about why we can't use HDFS to host data for production models, and we also talked about what we can do instead. We can't use HDFS because of the strict latency requirements that many models need to abide by in a production setting, and what we can do instead is typically use a distributed cache or an in-memory database if our data is small enough. That wraps up the data hosting video in the large-scale machine learning section of ML Expert. Thanks for joining, and we'll see you next time.